Sounds good.
Let's see. Well, looks like we have 0 attendees.
Okay.
Oh. Hi, welcome everyone. We'll start in a couple of minutes here.
Hey, Gina.
Hey there, sorry, I'm just joining now.
No worries.
Looks like everything's good though.
Yeah.
Great. Yep.
And
you
welcome
both.
everyone. We'll wait just another minute or two to let people join before we get started. All right. Jessica, are we ready?
Yeah, I'm ready whenever you are.
Perfect. Yeah, welcome everyone. Happy Wednesday afternoon or evening, depending where you are. Welcome to the webinar, to one of the webinars in the CLEAN webinar series. I'm Anna Gold. I'm one of the CLEAN team members, and we are excited that we have today, again, Jessica Bean is our speaker. Jessica has been presenting in this series for a few years now, and she's going to present about understanding global change. We've partnered together over many years now, and her framework is often used to pull together clean resources. So we are excited, Jessica, that you're here. Jessica comes from the University of California in Berkeley, the Museum of Paleontology, and is the author and the brain behind Understanding Global Change. Take it away, Jessica.
Thank you so much again for having me. It's always an honor because, as was mentioned, I use clean resources throughout my work. And I really see that the framework and the tools that I'm going to share with you today can really go hand in hand with the clean resources in the clean collection. So really excited to share that with you and explore how those can be used together. So just an overview for today. So I'm going to introduce you to understanding global change. You'll hear me use the acronym UGC throughout, and our project goals, like why did we develop these tools and what does their greater purpose serve in climate education. And then I'll introduce you to the framework and give you a tour of our website, which launched in its current form a little over a year ago. Some of these materials are also found on the Clean website as well. And then hopefully we're going to have some time to play what I call Earth System Shuffle, where you get to sort of experience the tools and think about how you might be able to use these in your own educational settings, whether it's in the classroom or more informally. So again, really excited to be here today with you to talk about these things. So first, understanding global change. So there really are sort of three main components that we have developed as part of this project. The first, as was mentioned earlier, is this conceptual framework that can really help to organize the complexity of climate change and global change in general. What are the topics, the causes, the consequences that we need to discuss if we're going to understand climate change and global change issues. And then what we really turned our attention to is developing tools for really helping users visualize how do they explain what's going on in the Earth system, what's changing, how much, how fast, and in what ways. So we use a lot of tools for constructing models of climate and Earth system processes. And then finally, a lot of the work that I do, both with school districts and also in professional learning communities, is to help teachers design coherent instructional units. And very often those units include clean resources, include parts from the clean collection, but it's a way of connecting together different resources from the clean collection using these tools and the Understanding Global Change framework. And there's a meme that I've used a lot throughout my work, which really sort of drives home this idea of like what we're really teaching is not just information, not just sort of discrete bits of knowledge about how the climate system works or what greenhouse gases are, right? But we're really trying to connect the dots, and we're really trying to help students have a sense of how all the different parts of the world are interconnected. And that builds knowledge that's transferable and usable, and can help actually solve the problems that we're facing today. And coherent learning requires just connecting these dots, right? That climate change isn't something that can be learned through just one or two activities, but how do we connect the dots and show how it is touching so much of and all of the world that we're living in today. So I do want to point out really quickly that I've not been alone in this work, that I've had some absolutely amazing partners, including Clean and HHMI Biointeractive. Our work has also been featured in National Geographic and Miller and Levine biology textbooks for high school textbooks. And we have received some funding from the California Science Project and work with them as well to, again, support professional learning communities and teachers in developing new units about climate change and global change issues. Because when I came on the scene and started working on this project, there were already a lot of great resources out there. Again, we have our climate literacy, energy literacy, ocean literacy principles and concepts, Clean itself, resources at globalchange.gov, the IPCC reports, NOAA, NASA, places you can go to find information about climate, the National Climate Assessment. But what we also need is a way to address the next generation science standards and the 3 dimensions of the next generation science standards in using data and information. And again, connecting those dots, putting the pieces together and really developing materials that help students build a coherent understanding of how the world works and why it's changing. And of course, with NGSS, we get standards that look like this. These are 2 performance expectations or system performance expectations from 5th grade and high school. So develop a model using an example to describe ways the geosphere, biosphere, hydrosphere, atmosphere interact. So again, this idea of using models and thinking about systems. And then at high school level, analyzing data, right, to make a claim that one change can create feedbacks to other Earth systems. So again, thinking about analyzing, interpreting data and stability and change. And so we want students to be able to engage in these practices of science and be thinking about these cross-cutting concepts as they learn about climate change and global change issues. But what we really tried to emphasize again is this idea of modeling and systems. So I just want to pose the question to you really quickly. 30 seconds, brainstorm on your own paper. What is a system? And why is thinking about systems useful? Why would we take this approach in the work that we're doing? So feel free to sketch a diagram or use words and arrows or whatever to express your ideas. So I'll just give you a few more seconds to do that. Oops, sorry. Let's go back. All right. So now what I'd like you to do is make your thinking visible. So I'd like you to share out on a Jamboard. I'm going to put the link in the chat right now. And what you should see if you click on that link is a Jamboard that gives you a space to answer these questions. Again, what is a system and why is thinking about systems useful? And just to remind you that a Jamboard works like this, you can flip to different pages. You don't need to do that yet, but you can flip to different pages at the top. And then I would recommend using the sticky note as a way to start to be able to add your ideas and thoughts onto the Jamboard. And let me know if you have any questions about Jamboard and how it works. But again, let's make our thinking visible. What is a system and why is thinking about systems useful? So now oh, you didn't see the link to the Jamboard. Oh, here we go. Let me put it back in the chat. Can you see it now? Should be working now. Ah, okay, great. Oh, I see some people coming into the Jamboard. Awesome. So again, the question is, what is a system? And then why is thinking about systems useful? Why would we take this approach in thinking about climate change and global change issues? Let me know if you need any help with the Jamboard. Not seeing any ideas yet showing up. Okay, we got one. Start. Think of a system as a series of moving pieces or processes that interact and affect one another. Okay, so something about interactions and things working together. Marine's asking, could I define global change? That's a great question. So when I think of global, when we use the phrase global change, we're talking about climate change, but also things that we wouldn't necessarily think of inherently as related to the climate system. So for example, things like invasive species or fishing and hunting might be affected by climate change, but it's not specifically the climate system. But we think of global change as encompassing everything that's related to climate change. And of course, we know that climate change affects pretty much everything and how invasive species operate and how, again, how we are able to use natural resources of all kinds. So I hope that clarifies for you a little bit. It's more of just an all-encompassing term that we use that includes climate change. Okay, and I'm seeing some more responses. So that systems are about interconnectedness, cause and effect, useful because it could determine impacts that could be unforeseen. Okay, interesting. So something about making predictions. Systems are collections of parts that interact in order to complete a function. Okay, useful to show how parts are related, connected, how they affect one another. A system defines an area of focus. So interesting. So thinking about maybe boundaries. So understanding systems help eliminate the noise of factors outside of the system and allows us to observe or to concentrate on the components that matter, the energy that flows. Interesting. Okay, awesome. Wonderful. So again, lots of great ideas here about what a system is and why it would be useful, everything from understanding interactions to making predictions. And I just want to show you really quickly that that's that's what I've seen from other groups of educators over the years, that we see this idea of trying to understand the bigger picture, that idea of interdependence or complexity, that, parts are interconnected. Again, arrows and diagrams that show those interactions. Lots of different ways that I've had teachers and students over the years express the ideas about, again, interactions and lots of different components and parts. And of course, NGSS gives us a definition, right? That a system, their definition is that a system is an organized group of related objects or components, and that models can be used for understanding and predicting the behavior of systems. So again, that idea of predicting was even mentioned in the responses that you gave, which is very important, especially when we're talking about climate change. And of course, NGSS also outlines that at different grade levels, students should be able to work with systems in different ways, systems and system models, so that in grades 6 to 8, students can understand that systems may interact with other systems. They can use models to represent those interactions, inputs and outputs. And by grades 9 through 12, they're really using models to investigate or analyze a problem, or and think about boundaries and initial conditions. And of course, you can look at all of that in Appendix G in the NGSS, which is great. And there's evidence to suggest, at least in adult learners, that systems thinking can really support an understanding of climate change, that you can have a more pro-ecological worldview, a more holistic worldview of how the world works and how we're all interconnected, and that climate change is cause for concern if you have some of these underlying tendencies to think in a systems way. So this is a study that was done by the Yale Climate Change Communication Group about systems thinking and the way that it supports beliefs and attitudes about climate change, global warming. And I also just want to point your attention to this paper that came out a couple years ago by Gillison et al., which really brings out this idea that to be explicit about systems thinking, to use systems thinking language with students, with learners, is actually really important, that we use words like thinking about boundaries and components and interactions, and that when you are intentional about it, when students are asked to think about these things, this is a worksheet that they actually provided in the research paper, which I thought was great, that students are much more likely to embrace systems thinking and use it and transfer it into new scenarios, to new examples. And the authors even gave some really great questions, guiding questions that can be used to get students to think about these different systems characteristics, which are very useful. So again, another resource that I would turn to, and that I've used as evidence of why we need to be engaging students in systems thinking, because ultimately what we want is that students will understand climate change and all of the interacting physical, chemical, and biological processes that are related to climate change and its consequences. So again, this just explains a little bit of the rationale behind the project, and why we've designed the tools that we have. So with this intention, with this purpose in supporting systems thinking and supporting this dimension of the NGSS, we developed what we call the UGC framework, and I'll also show you the website that we have created around this framework and supporting materials. And the purpose of this framework, and again, the supporting content and resources, is to help users discover why the climate environment changes, your place in the Earth system, and also paths to a resilient future. How do we solve some of the problems that we're facing today and use that systems thinking to our advantage? This is the homepage of the website at ugc.berkeley.edu. And you'll see that there's an easy way to just get started. So there's a how to use this website introduction. And the first thing that you will see is what we call this UGC Earth Scene. So this is sort of a generic oceans to mountains scene that is used as our backdrop for thinking about all of the systems connections that we want to understand around climate and global change. And this is sort of the place, this is a template where students can make their thinking visible and also improve their ideas over time as they understand more parts of the system that we live in. So you'll see a slideshow that, introduces you to this Earth scene, and it will also very briefly step you into this understanding global change framework. So what we've done is organize topics related to climate and global change into 3 main categories. The first is that there's the Earth system. So these are processes that have been going on for billions of years, really, that we've had the water cycle and ocean circulation and atmospheric circulation and the greenhouse effect. The rock cycle, right? These are big system processes that always shape the world that we live in. But then we can really think about what are the measurable changes? What are the things in that Earth system that we can measure and monitor over time to know that the world is changing, that the rate and magnitude of those changes are happening. So we can measure things like temperature or biodiversity or ocean acidification or sea level rise or airborne particles, right? These are things that we measure and monitor for various reasons, but the scientists all over the world are constantly collecting data about in order to understand how and how much the world is changing. And then finally, the last category in our framework are these causes of change. What are the ultimate reasons for why the world changes over time? And not just in the recent, which of course we're very concerned about, but also in deep time. If we have to explain changes over millions or tens of thousands of years, what are the causes? What are the reasons? So of course, today we need to turn our attention to things like burning of fossil fuels and our land use, agriculture, urbanization. But in the distant past, we can turn and on a smaller scale today, sometimes we can see things like volcanic events, right, that affect more local communities, but that aren't necessarily causing global scale changes. But we would have to turn in deep time over millions to tens of thousands of years to things like volcanism or meteorite impacts or major tectonic changes. So again, I'm gonna now unpack this framework for you. So this is just an overview. And so this is how we have represented this framework as 3 concentric circles. So showing the causes of change, which then put pressure on the Earth system, which we've divided into the 4 spheres: atmosphere, biosphere, hydrosphere, and geosphere. And then finally, measurable changes in the Earth system that we would measure within the system to understand how the world has changed over time. So again, this represents our Earth and all the different parts. So if you go to our What is Global Change part of our website, you could start on this page called Understanding Global Change 101, which will step you through the framework in a very similar way to what I'm about to do now. So there are a couple of slideshows that you can read through and at your own pace, of course, and you can download the slides to use however you want with students or learners of all ages. But again, what we do is introduce you to this framework, this concentric circle diagram. And the way we start is by breaking down this Earth system, right? How the world works, how the Earth system works. Because this is just this is an easier entry point I've found over the years, because this really gets you into sort of the fundamental processes that are part of K-12 education from very early on. The water cycle, the rock cycle. These are those the carbon cycle. These are those ongoing processes that shape the world through time. But we do have to think about, okay, where does the energy come from, right, to drive these processes? So this is related to sunlight, how much sunlight is absorbed and reflected versus heat that's re-radiated. And of course, Earth's internal heat in the geosphere. And we've also developed all sorts of graphics and content to help you unpack what do we mean by absorption of sunlight or re-radiation of heat? What does that mean? And then if we want to turn our attention to the atmosphere and the hydrosphere, again, I've already mentioned the water cycle, right, as one of those big ongoing processes, but also atmosphere and ocean circulation, which we know are very much related, and of course, the greenhouse effect. Again, supporting resources and diagrams to help you unpack these concepts. And then we can turn our attention to the biosphere and the geosphere. So processes like photosynthesis and respiration, evolution, species interactions, right, ecology. And then within the geosphere, we have our rock cycle and plate tectonics. We've also called out weathering here, specifically because of its role in the long-term carbon cycle and atmospheric CO2 levels. We can then connect the spheres through elemental cycles like carbon, nitrogen, and phosphorus. And if you add up all of these processes together, if you think about all of them together, they shape what we would call over the surface of the Earth our climate and our ecosystems, right? All of these processes play a role. And so that's why on this inner circle, we have added these words climate and ecosystems. So next, we're going to look at our causes of global change. And as I mentioned, we've sort of divided those up into both human and non-human causes, because in deep time, we have to be thinking about things that have caused global change in the past, which are still going on today, but not at a rate and magnitude that can explain how much the world is changing, especially over the last 200 years. But in deep time, over tens of thousands to millions of years, we have to look at things like changes in solar radiation or Milankovitch cycles or spin tilt in orbit or meteorite impacts. And then also major tectonic events, changes in distribution of continents and oceans, mountain building, volcanism, as I mentioned earlier. So again, lots of supporting diagrams and information about what do we mean by Earth's tilt in orbit? How does that change? Or what do we mean by solar radiation? We have these 11-year sunspot cycles. This is, Watts reaching the top of Earth's atmosphere. But regardless of these solar cycles that we experience today, we still see Earth's global surface temperatures rising, right? So that cannot be explained by sunspots or solar activity alone. So what we really have to do is turn our attention to human causes of global change. So that includes, as I've mentioned, things like burning of fossil fuels, agricultural activities, urbanization. As I mentioned earlier, we can think really broadly in terms of global change: invasive species, fishing and hunting, fresh water use, various pollutants and waste beyond, just greenhouse gases, but including greenhouse gases, of course. And while we have created a lot of problems, we also have, for ourselves ecologically, because of some of these activities, we also have the capacity to solve them. So we've also included some very hopeful language in this framework, things like renewable energy, innovation, right? We can reforest areas. We can also restore habitat. This is possible, and these are efforts that are happening around the world in order to sustain ecosystems and human populations. So again, we have lots of resources for thinking about what are these causes, what do they mean, what's involved, but also, of course, mitigation and adaptation of climate and global change. So, what does that mean, and how is this connected to other Earth system processes? So there's a content page for each of these topics, which I'll show you in a bit, that then connects to other topics in our framework. So the last part of our framework that I'll unpack for you now are the measurable changes in the Earth system. So again, what's our evidence? What's our data? What are the things that we're monitoring and measuring all over the world to understand how much and how fast the world is changing? And again, we've divided this up into our 4 spheres. And what we've done is, what we've noticed over the years is that actually these are the basis for phenomena. If you're doing NGSS phenomena-based instruction, that this is a great place to start thinking about what are the observable, measurable components of the Earth that could be then localized and be something that you would investigate about what's happening in the world and why is it happening, why is it changing. So this framework has been useful in identifying phenomena to anchor instructional units, because we can look at things like changes in ocean acidification or sea level rise or snow and ice cover. Of course, we measure weather on a daily, hourly basis, right? Over longer periods of time, we call that climate. But what we're actually measuring are these, weather and extreme events that are defined by things like, wind, clouds, precipitation, and temperature. And of course, we can measure things like greenhouse gases or airborne particles in our atmosphere. And so, of course, again, we have data and information to help you unpack what do we mean by greenhouse gases, what's the evidence for how greenhouse gases are changing, or how global surface temperatures are changing over time, or ice cover. Here's our ice reduction in the Arctic. And then we can look at our biosphere and geosphere. So we want to measure things like species population, species ranges, right? Biodiversity, fire. The biosphere is what burns. It affects the atmosphere, but but what's burning is actually the biosphere. And then of course, changes in the geosphere, things that affect soil quality or erosion, sedimentation, uplift and sinking of land, and also nutrient levels. And then at the very, very heart of this entire framework, we have the concepts, the changes that are most directly related to the quality of human life. So that would be our air, our food, our water, health and disease, displacement, where we can live based on climate and global changes. Because again, we have, we are a cause of global change, but we also must figure out ways of dealing with the changes that are happening around us that affect the resources that we need. And so these things most directly, affect our quality of human life, our well-being, and really the well-being of the planet and other ecosystems. So we have a lot of choices about, how we're going to think about our system and what role we play in our system that determine the quality of human life now and for generations to come. So this is our full framework. I'm showing it here to you all at once. The way I've introduced this to you has been, of course, very fast. And I would really recommend only doing it this way for, high school and above learners. We have some ways that we figured out of introducing it to younger learners and using, the simple framework and building up the complexity over time. But since you are adult learners, I felt that this was appropriate for this webinar. And there's a way that you can actually use this infographic to also navigate the site content. So this is a clickable version of the framework. So for example, I want to learn more about burning of fossil fuels. I could click on that page, on that part of the framework, and it would take me to the burning of fossil fuels page. And what you'll also notice then, of course, is on this page, there are links to the other topics that are on our framework. So you can navigate and look at the various connections across the Earth system from page to page. So let's say I want to learn more about temperature based on my reading of the burning of fossil fuels page. So again, there are great ways that you can sort of explore the content in a very nonlinear way, very much like an interconnected system. So I just want to show you very quickly, there are other ways of looking at the content on our website. You can look at the different content pages that are organized by the different sections of the framework. For example, in the measurable changes, you can get a list of all the measurable changes, but let's say you just want to look at things that are in the biosphere. You could click on biosphere and then just look at the topics like food or extinction or fire that are related to topics in measurable change topics in the biosphere. Okay. So I also want to point out again that we have these different levels of complexity, right, of the framework that I've mentioned can be used in different ways with different grade levels. We also have what we call the everyday language version of the framework. So for example, instead of saying ocean circulation on this framework, we say movement of water in the oceans, right, just to make it more accessible for everyone, learners of all ages. So this has been a really great tool that I've used, especially with elementary school students and their teachers. And we use this for planning, and then we use the components of this, which I'll show you in a bit, for students actually to show their thinking and make their thinking visible. So lots of options for downloading, different sizes, handouts, posters, also at different levels of complexity, of course. And then we also use this as sort of a word wall. Again, you can sort of build up the complexity over time. So what I've done here is just add the icons, the concepts that are relevant maybe to a particular unit that we're covering. And we could build that up over time over the course of the year. So again, but the ultimate goal is that students start to develop and articulate a systems perspective. They start to see how all of these different topics are related and interacted and shape our climate and our ecosystems. All right, so in summary, the framework really is a lens through which to sort of see the world and also think about science content. So again, we use it a lot in planning with teachers and also for students in terms of making sense, especially middle and high school and above, making sense of the world and what parts of it they understand and how they're interacted. they're interrelated. It's also kind of like a you are here map. That's how I like to think of it. So you can think about, what am I teaching today? What am I teaching tomorrow? Where do I want to go? What are my students, understanding and connecting? What are they not? What do I do to get them there? So for example, if you're thinking about or teaching about photosynthesis or species interactions, what are the other topics and things you want to connect to that? How do you make climate change a part of that discussion and exploration, right? Instead of just teaching photosynthesis as a process, or just teaching about, ecological interactions, but not connecting it back to how do ecological interactions change over time, or what might affect changes in both photosynthesis and ecosystems. Okay, so I've been talking for a while now, but what I would love to do is give you an opportunity to take a look at the framework for yourself and do some thinking. So I've created some frames on the Jamboard. If you go forward at the top of the screen, you can click forward and see copies of the framework that look like this. So just go through, and you, like, a few different people could be working on the same Jamboard. If you want to pick a color and claim that as your color, feel free to add your name to a sticky. Or there's enough space on this Jamboard. If you just go to a page, you can start circling and identifying, like, what are the things that you teach? And what are the concepts that you hope students will connect in the way that they think about the world and see the world when they're learning with you. So let me know if you're having any issues with the Jamboard link. I'll put it back in the chat in case anyone needs it. Okay, so I'm going to switch over to that Jamboard and see if anyone's starting to look at the framework. So again, feel free to claim a spot and just, oh, I also want to just point out that you can zoom in. Sorry, I forgot to mention that. You can zoom in so this becomes readable, right? So if you zoom in to like 200%, then you'll actually be able to read every single word that's on the Jamboard. So feel free to do that. It's on, let's see, the link should be in the Jamboard. If you go forward from the Jamboard page that it takes you to. Is anyone having trouble finding the pages on the Jamboard that look like this? You can let me know in the chat. Okay, I see some people look like they're able to sign on. So I'll just give everyone a couple more minutes to take a look at the framework. Again, remember that you can zoom in to make this readable. You can use the pen tools in order, oh, I see some circles being made. Awesome. And again, a lot of what we do with our teachers is we try to get them to be very specific, right? So like, let's identify the main concepts, and then let's also start drawing arrows, right? To show what those connections are. How are you going to connect the ideas in the framework and show how they're interrelated? What do you expect students will learn and understand about the real system and the way the world operates? So I see some arrows appearing. Awesome. All right. Very cool. So I'm seeing greenhouse gases connected to pollutants and waste, resource extraction. Let's see what's happening on some of the other pages. I see climate and ecosystems are circled, but then more specifically, energy budget. and how that's connected to, absorption and reflection of sunlight and population growth and burning of fossil fuels and pollutants. Okay, awesome. And looking at ecosystems and photosynthesis. And very often when we're, supporting teachers in planning and thinking about their units, we're trying to get them to do something that connects all three dimensions, right? So let's make sure that we're connecting a cause of a change in the system and what's our data, what's our evidence, what'll be the measurable changes that we'll look at. So I see someone else has circled some parts of the biosphere and the carbon cycle. Awesome. So again, lots of ways to use this tool to really push your thinking and think broadly about what you're doing, how you're doing it, and why. Great. Well, those Jamboards will be available to you if you want to look back on them and use them for your own purposes or make a copy. And again, very often I'll get also responses like this that are like, yeah, I teach the whole thing. But, again, the idea is to be really specific and intentional about what do you want students to learn? What do you want them to be thinking about? And so the extension of the tools, the more student-facing tools that we've built off of this project have really been, again, about this idea of taking information, but really turning it into interconnected knowledge, right? So understanding how invasive species affect species interactions or temperatures affected by greenhouse gases and connecting the dots across the different parts of the system. And so what you can do is you can take the icons, the different pieces of our framework, and really create system models that show those interactions and relationships. So here's the teacher's model that was created in developing a new unit about coastal ecosystems in Northern California. And this is from a workshop in Arizona, working with teachers who were creating a model on our digital tool, which I'll show you shortly. But there are lots of different versions of these icon sets that you can download and print out and cut up. Again, in the original and also that everyday language that I mentioned. We also have everything in Spanish and also Spanish-English double-sided in case you have students either learning English or learning Spanish. And then, of course, the Earth Scene, both in color and black and white at various sizes. So various ways you can support and provide the materials for students to make these types of visualizations of their thinking, of their understanding, using the components. And I should point out that very often we don't give students all of the icons all at once, right? But we will scaffold it and we will give them, 5, 10 at a time to, enhance what the ideas that they are expressing in their models to show systems interactions. Here's a screenshot of my colleague Jen Pierce at Boise State and a few years ago, working actually with elementary school students who are creating a UGC model on a projection on their whiteboard and drawing arrows and connecting the dots about their understanding of the greenhouse effect. And Jen has been working extensively in Idaho with teachers to support climate education in the classroom. And as I mentioned earlier, we also have a digital tool that's part of the Clean collection as well. We're honored to be there. And this is a great tool because it allows you to drag and drop icons and create models. You can also annotate the models and provide explanations of what do you mean by burning fossil fuels changes the greenhouse effect. And you can export this in all sorts of ways. Which I'll show you in a second, the interactive also has this clickable framework with lots of the definitions of the different parts in case students need to review. And again, as I mentioned, it's part of the Clean selected collection. Because what this allows you to do is really see how maybe students' understanding of different topics might change or be enhanced over time. So, and I've even used this in my own communication about my own research and the work that I do as a scientist. So for example, I have studied ocean acidification, but I really study ocean acidification and how it affects organisms in the ocean and their life cycles, right? And how they grow and how they reproduce. And if I'm going to explain why ocean acidification is happening, I have to understand that that's because of carbon dioxide, greenhouse gas in the atmosphere, which is primarily coming from human activities like burning fossil fuels and agriculture and because we're deforesting large areas of the world and various pollutants and waste. But the reality too is that as we increase greenhouse gas in the atmosphere, which I'm sure all of you know, we are also increasing our average global temperatures, which is also increasing the temperature of our oceans. And so really these organisms that I study are experiencing a double whammy, ocean acidification with ocean warming. And why would we care about this and how this affects, ocean species? Well, because that could affect the populations and biomass and interactions and species ranges. And we could expand, keep this this system model expanding into other human activities and resources and food and all the things that we need. So lots of connections you can make from land to air to water, right, to the biosphere. And so if you make these types of models in the interactive, you can export it in all sorts of ways. You can make fill in the blank templates in case you're using this for various forms of assessment or the way you want students to construct their models with or without arrows, worksheets that can allow students to provide their claim evidence reasoning, like explain the connections between these different topics. And you can also change the actual background on this modeling tool, so that if you're doing a unit about kelp forests, you could make the background a kelp forest, or the San Francisco Bay. This is a student model that was created in a unit about the San Francisco Bay and all of the different processes happening. And there are just so many different ways that we've used the icons and the framework over the years. And one that is new is, we call it Earth System Bingo. So it's a way of thinking about those types of connections. So you could have students or learners watch a video or look at a data set and then ask students to find the Earth system connections to that particular topic and data set. So the example you're seeing here is actually from a project I do about river otters in the San Francisco Bay. And we showed teachers a number of videos about river otter ecology and behavior. And we asked them to make connections to other parts of the Earth system and show what they know about the river otters by playing Earth System Bingo, which was really fun. So again, there are lots of examples of models and these types of Earth system connections on the website. So you can see those on pages like this one about the greenhouse effect. And then we do have pages that summarize sort of our teaching resources and ideas for planning for instruction and example units and lessons. So ideas that I've shared with you today, like using this as a word wall and how you would construct a model for planning and starting a unit. And again, thinking about phenomena and how you would ground and anchor a unit in thinking about climate data. What's the data and evidence that that students are going to explore as they come to understand climate change and these parts of the Earth system. We do have a number of units that are now posted on our website. The sea level rise unit has been used pretty widely. We actually did a test a number of years ago with over 1,000 students. And as I mentioned earlier, really contains a lot of clean resources. The goal is to link together high quality resources, data sets, visualizations, interactive labs and games that really help build an understanding of a more complex understanding of sea level rise, why it's happening, and also what do we do about it? What are the ways that we can adapt and mitigate sea level rise? And so ultimately, when students are done with this unit, they are making these specific connections across the Earth system. So we would expect that students would be able to explain all these arrows and the interrelationships. Again, connecting things from land to atmosphere to ocean to how this affects human populations. And on our website, we also have the Understanding Global Change Unit Planning Guide, which we've used in lots of professional learning communities to support teachers in, again, using this tool to think about how they could construct or modify a unit using clean resources and emphasize that systems perspective. And we just posted in the last week some new drafts of units that are coming out of a couple of grants. One from the California Science Project in collaboration with the Lawrence Hall of Science at UC Berkeley, and another on a NOAA BWET grant with Marin County Office of Education. And so these are the new units that are available now in draft form, and we'll be finalizing them in the next few months, but feel free to check those out on our website. And so at this point that I've given you sort of the overview of the resources that we have available on our website, but we'd now like you to just spend a little bit more time thinking about, again, the tools and how you might be able to use them by engaging in what we call our system shuffle. So the purpose, again, is that you can just sort of think about this more as an adult learner, but also become more familiar with the tool and think about how you could use this with your own students or learners. And there are lots of different ways you could do this. This is just one of them. You could use breakout rooms, or you could do this more as an asynchronous activity. It's really up to you. But I'm going to just step you through it in the last few minutes that we have. So if you go to frame 12 on the Jamboard, you don't have to do it quite yet. What you'll see is a bunch of icons, and I want you to select one. So let's say I select agricultural activities on frame 12 of the Jamboard, and the Jamboard page looks like this. So again, lots of different options. Pick an icon that is appealing to you, is of interest to you. Thanks, Gina, for reposting the page. And so then try to use the copy keyboard command to copy it. Don't paste it yet. But then I just want to tell you that on pages 13 to 18, what you'll see are these 6 icons. These are measurable changes. And so what I'd like you to do is now think about which of these measurable changes is your icon that you selected. So I selected agricultural activities as an example. Which page would I go to be able to explain how agricultural activities are connected to one of these concepts? So I'm going to pick health because I have some feelings about and ideas based on my prior knowledge about how our health is affected by various forms of agricultural activities, both in positive and negative ways. So I'm going to then go to that health page, and I'm going to paste my icon onto that Jamboard page, onto that Earth Scene. And then I could use words or arrows or other ways to express my ideas and show that relationship to health. And you can also feel free to use any of these other 4 icons that we've provided on the side to enhance your model. And so the idea is that, okay, so now I've contributed my concept, my icon, agricultural activities, to the health page. So now I would like to go to another page. So I can take a few minutes and think about, okay, well, now I think I'm going to go to the biodiversity page and explain what I know about how agricultural activities are related to biodiversity. So are there any, let me know if there are any questions. I'm going to flip over to the Jamboard page and see if anyone has selected some of the icons on page 12. So again, you can just click on an icon and copy, and then go forward and paste. And if you are having trouble copying and pasting, you could also just make a sticky that says that icon on it. So that's another way around it if you're having any sort of technical problems copying and pasting. So again, this is a really great activity that you can do with your students that really gets them to stretch their thinking about all of those Earth system connections. What do they know? What do they think they know? What do they maybe want to know? And also, you know, allows them to sort of explore different aspects of the system. And you could make each of these pages about a particular topic or a phenomenon that you've explored in your class. And so you could add more and more icons and topics over time. There are lots of ways of doing this. So I'll just give you a few more minutes to do that. Copy and paste some icons, maybe start to show some connections. And I'll just show you really quickly that we also do this in person using, you know, posters and pens and the icon cards, which has been really great. You can set up different stations around the room. This does not have to be a virtual activity, of course. See if anyone's made any connections or contributions. Not seeing anything yet. Oh, I see some, okay, on freshwater quality and availability. Awesome. So ideas about snow and ice cover, fresh water use. Awesome. So again, once you've contributed to that Jamboard, you can then take your snow and ice cover or your freshwater use icons and go to another topic and stretch your thinking about the connections there. Okay, and I know we're running short on time, and I do want to leave some time for questions. So I just want to show you what these Jamboards can start to look like over time. And again, we really try to emphasize that students write out connections about their ideas, right? Provide an explanation. Drawing arrows is great, but as you saw that some participants were already doing, writing a sticky with an explanation or some other information. There are lots of ways you can extend this activity. You can shuffle the breakout rooms and have students share models or combine models. You can also try to build a consensus model with lots of, the key connections that students are making. And again, as I sort of already mentioned, you can select a subset of the icons and increase the number over the course of the year, and really have participants revise and extend their models after various learning experiences throughout the curriculum. So again, I've been really honored to work with so many amazing teachers and educators, and of course, CLEAN, in figuring out how we can leverage these tools to connect the dots and support this systems thinking in the classroom. And so today I gave you a quick overview of these three main tools, which is that conceptual framework, the modeling tools for constructing visualizations, and then finally resources for designing coherent units, like our instructional planning guide that we've developed to help you use clean resources and connect them together, and use modeling as a practice in your instruction. With that, I'd just like to thank my team, both at UCMP, our advisory board, and also at our partnering institutions, HHMI, that helped us build that interactive that I shared with you. And please feel free to reach out to me and check out our website, follow us on Twitter for announcements about future events. And thank you again to CLEAN for having me. It's great to see you again and be here.
Thank you so much, Jessica, and thank you all for those that stayed on. There's a recording available, of course, for anyone who had to hop off earlier. We're happy to take a few questions, but we know time is already pretty far along. So yeah, if you want, just put a raise your hand, or just type a question in the chat.
This is Gina, actually. We had someone asking, Maureen asked if you could link to the Yale study on systems thinking or any of the other studies that you mentioned. It seems like she was looking for some more information about that.
Yes, give me 1 second and I will find that link and I'll put it in the chat. I'm going to stop sharing for a second, but that's a great question.
And in the meantime, check out CLEAN if you're not familiar with it. It's been referenced a lot of times, but there's lots of resources, more webinars coming up. And yeah, we have a lot of support for teachers also for background information on climate and energy topics, or how do you teach about misconceptions and in the classroom and things like that. Thanks, Jessica.
Yeah, I just put that one in, and then I'm going to give you the link to the Gillison paper as well that I mentioned. Those were the two papers that I shared. So.
All right, with that, thank you all for staying on, and we really appreciate your time. Jessica, thanks for a really engaging webinar again. It's always fun to hear about the framework and the resources. Yeah, and see you at the next webinar.
Thank you so much for having me. Thanks, everyone.
Bye.
Thanks, Jessica.